Hello again, Algebra 2. Here is part 2 of our Chapter 2, Section 1 video. We just ended with this question. Let's keep going. Example 3. Here we are. Let my puppy dog back in. Sorry about that. Here we are. I would like us to graph this relation this time, determine the domain and the range, and is it a function? That is the question. So again, I recommend an XY table. Pick some negatives, pick 0, pick some positives, see what's going on here. This one's a little more interesting. I have x squared this time, so be aware on your calculator, parentheses are your friend. Parentheses are your friend in this example. Because whenever we square negatives, we need to make sure the calculator knows that we are still going to get a positive. So here we go. Plugging these in. Plugging these in. I'm going to have negative, well I should say y equals negative 2. I'm going to square that plus 1. I get 4 plus 1, which is 5. And then I get, when I plug in negative 1, square it up, plus 1, I am going to get positive 1 plus 1, and that's where I get my 2 from. Okay? When I plug in 0, I'm going to get 0 plus 1, which is just a nice 1. When I plug in positive 1, square it, add 1, I am going to get 2. And last, but certainly not least, and you can pick different numbers too. You can pick different x values as you do this. I just like this little range in the middle. It's easy to work with. Last one, when I plug in 2, I am going to get 5. Ooh, so this one's 2, this one's 5. There we go. Okay, so notice the symmetry that's going on here. I'm kind of hovering around 0, and then I am symmetric after that, off either side of 0. So let's determine the, well, let's graph it first. Let's graph it first to see what's going on with the graph and see what this actually looks like. Hopefully this looks familiar to you, the equation itself. So here we go. Negative 2, 5. Over negative 2, 1, 2, 3, 4, 5. Negative 1, 2, 0, 1, 1, 2, 2, 5. Okay, interesting. Again, hopefully you've seen this shape before. Anyone know what this shape is called, is what I might ask you if we were in class. This is going to be a parabola. And what we want to do is make this a smooth curve, as much of a U shape as possible following these points. Again, arrow showing it could keep going higher and higher, curve it around, and it keeps going higher and higher on the other side as well. So that's my shape, a little bit different than the line that we had earlier. So let's talk about this parabola, what my domain and my range are. So my domain. Again, what x values can I plug in? I'm hoping you're seeing, well, I can square anything. I can square negative numbers. I can square 0. I can square positive numbers. I could square decimals if I wanted to. I didn't need to for this case because I just needed a quick set of numbers. But I am allowed to plug in anything. Therefore, my domain is still all real numbers. The range, though, is a little different because look at this. My range is my y values. I have some range values up here, but I don't have any graph below that. So I need to say that. I need to say that in my range. So what I'm going to say is my range is y values, I'm going to use an inequality here, y values that are greater than or equal to 1. This was the lowest point that I went, the 0, 1 right there, and I went above that. So y is greater than or equal to 1. I got down to 1 and I went above that, nothing lower than that. So that is my domain and my range, and then I ask myself, is this a function? And hopefully you're saying, yeah, obviously, vertical line test, it's right there in front of me. Anytime I have a vertical line, I'm only going to pass through the graph one time. So there we have it. So this is a function. Alrighty, last page, and I didn't write this on the note sheet itself, but I have a side note that I want to get into before we tackle example 4. And here's that side note. It's another kind of vocab word, and it is function notation. And what is function notation? You've seen it. I promise you've seen it. It's just a matter of knowing that it's called that. So notice in these last two examples, I used y equals notation. Y equals notation. Function notation is when you say instead of y equals something like 5x. Function notation is when you say f of x equals 5x. It's literally the same function. It's exactly the same. We are just swapping out the y for f of x. So, again, I read that f of x, pretty much saying this is a function. That's what the f stands for generally. A function where x is my independent variable. So, I can have other letters too, like I could do g of x, or I could do h of x, or I could do f of a, or f of q, whatever. Those letters are just arbitrary, but this is the one that we see the most often. F of x, that is function notation. A quick point that I often see people make this mistake. This is strictly notation. There is no multiplication there. No, ooh, too many bumps on my M. Multiplication here. It's just f and x sitting next to each other. There is no multiplication. There is no math to be done between the f and the x. You're not multiplying. You don't need to isolate the x, whatever it is. So just keep that f of x notation. Whatever my x value is, I am going to plug it into my function. So, keeping that in mind, let's talk about these functions up here. Given the function f of x equals 2x squared minus 8, find each value. Find each value. So part A, I want to know what f of 6 is. So this is me saying I want x to equal 6 in this situation. What is the function value at 6? Function value, which is the same as the y value at 6. That is the question. So let's take a look. All I'm going to do is plug in 6, which we were just doing on the other page of the notes. So I'm going to take f of 6 is 2 times 6 squared minus 8. Order of operations, I do the exponents first. So I have 2 times 36 minus 8. That's f of 6. F of 6. I'm going to go to my handy-dandy calculator just to make sure that I get this right and don't mess up my math. I have 2 times 36. I get 72. Minus 8. I get 64. So f of 6 equals 64. That tells me that if I were to graph this point, it's an ordered pair, and that ordered pair is 6, 64. That is my x, y ordered pair. Now, part B is a little bit different. Let's take a look at that. I'm going to plug in 2m this time, which is a little bit different because there is a variable in it already. But I can handle this. It's just a matter of simplifying with my order of operations. So again, this is what's happening when x equals 2m. When x equals 2m. So I'm going to take 2 times x squared, but that's 2m squared, minus 8. Order of operations, I need to do the exponents first. Notice what's happening here. Let me use another color real quick. This is 2m multiplied by 2m, which is 4m squared. 4m squared. So I'm going to go sideways on this one. I'm going to draw a squiggle so we keep it separated. I have 2 times 4m squared minus 8. 2 times 4m squared minus 8. Okay? Then I'm going to multiply this 2 and this 4m there. So I have 8m squared. I don't need to distribute here because I am not adding the 4 and the m squared. I'm multiplying. So I have 8 2m squared minus 8. And these are not like terms, so this is my final answer. So this right here is my final answer. So f of 2m equals 8m squared minus 8. Looks a little clunky, but it's a good skill to know how to have, just to work with some variables to get a function value. So that's all I want to talk about in this section. It's a lot of little things. Hopefully a lot of them are familiar to you. Maybe some are new. But there you have it, and we will talk about this in class very soon.